Let's look at an example of hypothesis testing. Now, many of you know that I was a pastor in France for 17 years. So I spent most of my adult life in France, and my wife and I, we were responsible for trying to start new evangelical churches, churches that believed the Bible, what Jesus had to say to people, and start these evangelical Protestant churches in different areas. And so in the 1990s, we moved to a town called Bussy-Saint-Georges that had no evangelical church in it. And one of the tools that we used to um, help the church grow were these brochures that we had printed up. Now, these turned out to be quite controversial brochures because they were in lots of colors. Colors didn't quite come through on the scanner here, but this was the 1990s when four-color printing was just becoming quite affordable. And we some people thought, well, you can't have church brochures that brightly colored because nobody had ever done it that way before. Um, and so some people were kind of skeptical of it. And so suppose we want to find out if the church brochures actually work. So this is approximately what our situation was here. And so let's say that we normally when we don't distribute church brochures, there's a visitor that comes to the church about one out of every 4 Sundays. So normally visitors come about 25% of the time. And let's say that we distributed the church brochures 5 times, and 4 of those Sundays after the distributions, people came. Now, normally we'd only expect them to come about 1 out of 4 times, but they came 4 out of 5 times. Our hypothesis is that the church brochures caused visitors to come, that they influenced the number of visitors to come, and that's why there was an increase in visitors. And so we want to see if we have evidence for that. Now, we can phrase this in terms of a null hypothesis. The null hypothesis is that the visitors came by chance, that the brochures didn't have anything to do with it. So what we want to do is we want to calculate the probability that we would get visitors coming 4 out of 5 times just by chance. We want to calculate the probability of this null hypothesis. And if the probability of the null hypothesis is really small, we'll say, no, it didn't happen by chance. That number of people must have been because of the church brochures. But if the probability of getting that many visitors by chance is fairly high, then we'll say, oh, that's nothing to write home about. The brochures might not have had anything to do with it. So the cutoff point that we're going to use, our alpha is going to be 5%. So we're going to say alpha equals 0.05, or we could say equal 5%. So what that means is that if there's less than a 5% chance of getting that many visitors if there's more than a 5% chance of getting that many visitors by chance, we're going to say, we don't have any evidence that the brochures worked. But if there's less than a 5% chance that we could get that many visitors, we're going to say, oh, the brochures probably worked. So that's what our alpha level is going to tell us. It's a cutoff point between who knows, or whoa, that was too freaky to happen by chance. They must really have an effect. So we need to calculate the probability of visitors coming 4 or more times during 5 Sundays by chance. Now, the way that we've phrased this is a binomial distribution. Visitors either come or they don't come on a Sunday morning, and there's a 25% chance that they're coming. So the P event that we're interested in is a visitor coming. The number of P events that we want to calculate the probability for is 4 or 5, because we want to know the probability that 4 or 5 visitors would come during a 5-week period, or come on 4 or 5 Sundays during a 5-week period. The number of trials is 5. We're looking at the 5 weeks that we distributed the brochure. And the probability of a P event happening by chance, a visitor just coming, is 0.25 because they came 1 out of 4 Sundays. And cumulative is going to be false. We're going to calculate the 4 and the 5 together. We're going to add together the two numbers like we did in the alternate form of one of those previous problems. So the probability of 4 or 5 of visitors coming on 4 or 5 Sundays by chance is going to be the probability of 4 visitors coming on 4 Sundays by chance, plus the probability of visitors coming on all 5 Sundays by chance. So we're going to use the formula that we have here. I'm going to type it again. We'll do equals binom distribution. Now the probability of getting 4 is 4 P events out of a total of 5. The probability of getting a P event is 0.25, and it's not cumulative, so we put false. And then I'm going to do plus the same thing for 5, binom dist, and the probability of getting 5 visitors on all 5 Sundays out of 5. And there's a 25% chance that they'll come, and it's not cumulative. I press enter, and that equals 1.56. Let's change that to let's change it to percent, 2%, and let's add a few more decimal points. So we've got P, so we can write control IP, that's the abbreviation for probability, turn off the italics, equals 1.56%, which is less than alpha equals 0.05. Therefore, we reject the null hypothesis. We have found good evidence that the brochures work. Now, we haven't proved that the brochures worked because whenever we have an alpha of 0.05, that means that there's a 5% chance that we're going to get a false positive. That 5% of the time we would get these things to happen by chance, but we have found some good evidence that that they did work, because getting these types of results just by chance probably wouldn't happen. It's only a 1.5% chance that would happen. So this is an example of hypothesis testing where we formulated hypotheses and then the null hypothesis, and then we calculated the probability of the outcomes that were more extreme than what we were interested in, and thought that probability was less than our cutoff point of 5%. Therefore, we rejected the null hypothesis, and we found good evidence for our hypothesis.